DevOps and Azure containers. Thank you so much for coming to our session. As a reminder, please silence your cell phones. This is being recorded. We are live on TV. Andy, can you tell us a little bit more about everything PASS has to offer?
Yeah, so there's a lot going on here at PASS this week, and we realize we're being streamed on PASS TV. Hi, PASS TV people. But in addition to the PASS Summit and the streaming capabilities online, there are free online webinars, local user groups, free one-day local training events, as you see here on the slide, other special interest virtual groups that are out there. And we just want to encourage you to go to pass.org and learn more about all these offerings.
Thanks, Andy. So, my name is Elizabeth Barron. I am a Senior Managing Director at Teach for America, a nonprofit in the US. I run the data platform team. And my role as a data platform lead is really to advocate for technical and cultural changes that make it possible for us to deliver the highest quality, most efficient, and most cost-effective data platform possible for our nonprofit.
Hi, my name is Sreeja Pullagura. I am the DevOps tech lead at Teach for America. My role is to work with teams within Teach for America to help them come up to speed with DevOps practices. I'm going to talk about some of that in the presentation today.
My name is Andy Leonard, and my official title is Chief Data Engineer at Enterprise Data and Analytics. I've created a suite of tools called DILM Suite that you can learn more about. I'm mostly a husband, dad, grandfather, and the occasional farmer, as the slide says. Thank you. Just one note about this. There's these levels that you're going to see assigned to presentations. And I think they're a little unfair because it's really hard to nail this down to a scalar. So what we did was we looked at the levels of material we're going to present here on 100, 200, 300, 400, and we see there's a smattering of all. You may disagree with our levels because some of you have experience doing this kind of work, working with containers, working with Azure DevOps. Show of hands, who's working with Azure DevOps right now? So this may be, you may look at these levels and at the end of this go, you know what, that was low. But if you're brand new to Azure DevOps, show of hands, brand new to Azure DevOps, okay, you may look at this and go, wow, that was really advanced. This is all normal. So what we've done here is try to capture how we feel the level of this presentation, how it goes.
Can I ask a couple more survey questions? That was so instructive.
Sure.
Has anyone deployed a SQL Server on a container? Is anyone working with SQL Server on containers?
Okay.
Excellent. What about those containers on Kubernetes? Fantastic.
Okay.
Sreeja, any questions from you?
What about running SSIS packages on the containers?
Nice.
Okay.
Nice.
Okay.
Thank you.
Couple people. Great. Well, this is going to be a lot of fun. I'm really excited. We've worked for weeks on this. I think we have great material, so let's get going. We're going to talk a little bit about our mission and the team because it's so much a part of why we're doing the things we're doing and what we think is important. We're going to talk about our vision for at least the cloud CI/CD, and CI/CD is for continuous integration and continuous delivery. It's really about the DevOps work that we're doing. We're going to walk you through hopefully 3 live demos if we have time, and then we'll talk a little bit about the end, about looking ahead, and we will obviously take questions. So with that, let me tell you a little bit about the mission of Teach for America. As you can see up here, Teach for America finds, develops, and supports a diverse network of leaders working together to end educational inequity. Shockingly, in the US, 16 million children live below the poverty line, and 2 times as many of those children are children of color. And I think, as we all know in this room, your educational path makes a huge difference to where you get to in life. And that's what makes our work on DevOps and SSIS CI/CD so critical. We really need to come together as a team to change our culture, to change our technology, so we can deliver business value as quickly as possible to our constituents. And those constituents are the children in the US. So who is our team? When we think usually of our team, like I run a data platform team, it's database developers and integration services developers. But when we think really the cultural change that needs to happen around what we do and how quickly we do it, we actually expand our definition of team so that we can be successful. So we have the DevOps team, our data infrastructure and operations team, our Windows operations team, and our data platform team. And all of those teams coming together has made what we're about to show you possible. With that, we're going to move on to our vision. So what is our vision and why? Sreeja.
Yes. So let's talk about the miracle of DevOps. And as an example from within Teach for America, I'm going to take you back to 2017, where Liz and her team, they were working on a project which was not fully automated. The builds, deployments, unit tests, nothing was there. So when Liz started leading the team, she wanted to have better code quality, higher unit tests so that she can, with more confidence, tell to her partner teams that their code is bug-free. And she wanted to have artifact management. You want to deploy a certain version of your code. The artifact management has all your code packaged and available there, and you could deploy a certain version based on your business reasons. And she also wanted to have code reviews. That means as a developer, let's say I'm working on developing a code, and I would give that for code review. Liz would come in and see my code and tell me, hey, Sreeja, these are certain places you could improve this code for better performance, better functionality, and also lesser bugs. And as a result, she would know the code I have written, and for some reason I'm not available to continue on that, she can take over. All this means shifting left. The idea is you are moving all your testing into way left in the development cycle. As a result, when you are close to your production release, less or very few chances of finding a critical issue which could be showstopper, which could be so expensive to fix that 1 or 2 days before the release. And because everything was manual, there was no build of the projects. People on the development team, they had higher privileges, which was not required to deploy. And there wasn't much unit testing. The QA team used to come in and test. We automated all that. We have pipelines to build the code for SQL Server and SSIS. We have unit tests, which now the developers are really loving and enjoying to write. And we also have deployment pipelines, which on code commit builds, tests the code, and if everything is successful, pushes to the environments. Ultimately, what we have is continuous integration and delivery. As a result, Liz, when she embraced the miracle of DevOps, her team and her partner teams are happy. She can deliver higher value, and she can even deliver faster. Recently, there was one requirement from business teams, which used to take at least a week, but they could turn it around in about a day, right, Liz?
1 day.
1 day, yes. So now Liz will talk more about the cloud vision we have.
Thank you so much, Sreeja. So let's talk about what this might look like. There are some question marks up here on our Azure Cloud CI/CD vision, because this is just one way we tried to do it. We put this together in the last couple of weeks. It's a basic straight Azure component replacement for what we have on premises. So this is basically what it looks like on premises, just with different tool sets. So let's see if this will work. No, that's not right. Yes, look at that. All right, so we have our repos here. On-prem, we use Bitbucket, but it's a Git-flavored repo. So on the cloud, we're thinking about Git or Azure DevOps repos. We still use, in either place, we use Microsoft Visual Studio, and we have clone and pull requests. So we have clone coming out of our Bitbucket or GitHub repo, and then we have pull requests to have them come back in. So the magic, the real magic is right here. It's in Azure DevOps pipelines. On premises, we use Jenkins, but Azure DevOps pipelines is a fantastic alternative if you're going to be on the cloud. So Azure DevOps pipelines picks up when I commit code, or any of my developers commit code, and it automatically starts to run whatever it is that we've asked it to run, and we've done that with a series of tasks. There are some gotchas at the moment, but I think Andy might tell you some really interesting things either today or Friday about SSIS and compiling it on the cloud with Azure DevOps. At the moment, you must have a self-hosted agent. It just isn't possible to do it with the Microsoft hosted agents. So we built our own. That wasn't too bad. And once you've got your self-hosted agent up and running, you start running your tasks, building your artifacts. And for us, SSIS developers or database developers, our artifacts are DAC packs and IS packs. That's what we get when we do a build. We will show you today that once you've got that artifact, we are going to put it in our Azure DevOps artifacts feed. So this is critical for rollbacks. Hopefully you don't have to roll back. Maybe just roll forwards. But saving your artifacts and be able to prove what you deployed. At the moment, there are no open source static code analysis tools like there are for Java or others. But SonarQube is one thing we had in our mind. We're not going to show you that today. It's not ready. We have lots of cool things, but something I just love is T-SQL-T. I think Sebastian Miney is not in the room, but he is the inventor and main contributor for T-SQL-T, and it is a testing code. It's a framework for testing databases. And with a couple of modifications, which are non-trivial, you can have it test SSIS too. And that's what we're going to show you today as well in one of the demos. It is so slick. And then for those of you interested in Kubernetes, there are a couple of ways of getting containers up and running on Azure, right? There's Kubernetes. There's Azure Container Instances. You can do IaaS, set up a VM that's your Docker host. What we found when we did our research was that Kubernetes is absolutely, at the moment, the easiest way to do this. It just provided the most functionality, and we could run almost any number of pipelines for our code, especially if you have auto-scaling on. So we might talk a little bit about that as well if we have some time. So you'll notice, again, like these question marks out here, and I would just like to hand it over to Andy if he has any comments about those question marks.
So I'll be able to talk some more about this in my presentation on Friday, but there is new technology that will become available soon.
Amazing.
That's all I'll say today.
Friday, what time?
Friday at, I think it's 11, not sure.
Friday at 11.
Yep.
Andy's presentation. Don't miss it. It will answer those question marks. All right. We're going to move along. We're going to move along to our live demo, because that's what we're here to do today, is actually show you what we've done, and hopefully you can take something away from this. Just as a word, if you want the code for this, it is up on GitHub. If you download our presentation, the last slide, or one of the last slides, actually has the code. It has information about how to set up Azure Kubernetes services. It has, especially for Windows containers, because we're using Windows containers, because I don't know how to run SSIS on Linux containers at the moment. Windows containers is absolutely what we needed. So AKS, one of the only places in the world you can run Windows containers at the moment on Kubernetes. So let's do our live demo. How do I go back? Here we go. All right. We are going to start with, let's see. Sreeja's. Please give me a minute to find the correct pipeline.
So what you,
Yes.
yeah, sorry. I'm going to drag that over. There
Yep.
you go. Good job.
Here we go.
Okay.
So here's Azure DevOps. And I know a lot of you are familiar with Azure DevOps. We've set up two pipelines. The first one we're going to talk about is the SSIS CI/CD demo, because that's what we're here to talk about today. And then we're going to break it down into two more parts. The other two parts we're going to talk about are testing, like actually making a unit test together, and then critically, the artifacts feed. So let's get this going. Let's queue it up. And then we'll walk through it, because it's live, right? This is a demo. Demo is true. And then make it go. Oops, that didn't work. Hold on. Where's my pointer? There we go. Run. All right. So that should actually start a run, because Azure's not down. And here we go. We're waiting for the request to be queued. And as we wait for that request to be queued, I do want to show you that we did set up our own agents. And this one is currently running on our build agent 5. I highly recommend when you set up if you're going to do this, when you set up your build, when you get your build agent just perfect, you make a custom image of it, and then you can fire those up at will. But let's look at our agent pools. You can see our default agent pool, and we've got a job running here, and here are our agents. So we've set up 3, for redundancy, for demos. So we have something running on Build Agent 5. What is running? How did we make that vision come to life? So let's go look at that pipeline. So some of you may be familiar with the UI, like the actual visual editor. We have chosen to use YAML. I think it's a little bit, it's probably not easier to understand, but it was easier for us to put together. We started with just the simple template, and then we started walking through. We named our project something. I think our team project is SSIS CI/CD. We set up some variables like the project name, so we didn't have to type that everywhere. And critically, when we check in code, so this is how Azure DevOps figures out what it should be listening to. It's right here on line 11. Can you all see line 11, or is this too small? I see some good. All right, so it's good. All right, so this master branch, not good practice, but we're doing it for the demo. When you listen to the specific branch, this is the branch that is building. So when we check something in to master, this pipeline will kick off. We've done it manually right now, but you don't have to. When you're developers or when you go ahead and make some changes to your code, these pipelines will automatically kick off, and it's beautiful. As you can see here, we are using the default pool. The default pool is the one that has our build agents in it, those self-hosted build agents, because they include dev env, which is SSDT, so SQL Server Development Tools. We just installed it on that box so that we could use dev env to actually build our SSIS projects and our database projects. We go ahead, and this is where the steps start. We're checking out our code. We have a PowerShell task to actually build the code, and you'll see here, if I scroll over or make these tasks go away over here, I'm using the devenv.com, and I'm building a solution. I send it my solution.sln file. I have 2 different builds for no particular reason, and then the project name. So I'm doing a DT_proj file and a SQL proj file. Those will become critical in our next demo because the DT_proj file is the SSIS project, right? The SQL project, the SQL proj, is what we've used with T-SQL-T, which is, again, amazing. I cannot say enough about how amazing it is. That's where we're putting our unit tests for SSIS. We publish the build artifacts. Let's see how our job is doing. Let's just check. How are we doing on this? So it's whirring away. Is this right? Yeah. It's whirring away. And we've actually gotten pretty far. We're deploying those unit test DACbacks that I just showed you how we were building. And when it actually should be up here someplace. When it's done, it'll show us. But the artifacts that we have, that task to actually publish the artifacts, when you publish it to the pipeline, for every single pipeline you run, that artifact will sit there so you can inspect it later. It's fantastic. And that's a very simple task to do. And I kind of love Azure DevOps. That's all it is right here. I'm publishing the ISPack file. I'm publishing the DACpack file to that pipeline. It's fantastic. This is my favorite task ever. I don't think I would have ever said that before, but Azure Key Vault has a fantastic integration with Azure DevOps. You simply add this task and say, give me all my secrets. And Azure DevOps will pop them into variables for you, all of them, or whichever ones you filter for. And you can see an example of that here. MVM cred is not defined anywhere except for Azure Key Vault. And yet I can use it right here. I can bring it into my PowerShell script and use it to actually publish with Maven, which is one of our tools that we're particularly familiar with at Teach for America, to publish to an artifact feed. So Azure Key Vault, the task, fantastic. Then we have our Kubernetes tasks. So Kubernetes I'm not as in love with for the tasks because it's really difficult to get information out of these tasks. They're one way only. I can do something. I can create a namespace. And for us, for every single one of our pipelines, we create a namespace in Kubernetes. And what that means is we've cordoned off so that it's completely isolated, a place for us to do our work for this pipeline. That's what we do. That's a best practice in the Kubernetes community from what I understand. So we have this pipeline created. We have a namespace created for the pipeline. We set up some secrets so we can get to our container registry, because that's where our container image lives. Sreeja will be telling you a lot more about what that container image looks like, or rather the Docker file that creates it, and how we were able to include SSIS and actually some prepackaged schemas. So this was a little bit easier for us to do. We're applying the deployment. When you apply deployment, that means you're setting up, you're pushing a pod or saying, I want this pod to exist in my namespace someplace. So we say the pod is related to a container. You can have one or more containers within a pod in Kubernetes. And basically what this does is ask Kubernetes to schedule or deploy that container to the namespace that you just isolated specifically for the pipeline. This is what I don't love. You do have to set up some scripts to go ahead and get the pod name so you can do things to the pod or do things to that container. And then you create the service so that we can get to it later and deploy SSIS or other things on it. So that once we get the service, that service creates an IP address for us. We'll definitely be looking at that. And then we go ahead and install the SSIS package. So again, you can see this all happening. Let's just show you right here. Great. So we've talked about setting up the secret, the deployment, logging into Azure Cloud, download and install the SSIS package. So this is a script. It's a PowerShell script that Sreeja is going to talk about, how you actually, on the container itself, run a script to download from artifact feeds and install your SSIS package right on that container so that you can run unit tests against it. It's amazing. It takes a little bit longer to deploy the unit tests. Don't know why. It takes up to 6 minutes, but it does. So here's the download and install. Now we're deploying the unit test DAC packs, which take a little bit longer. We're using SQL package here. Again, it's a PowerShell script. And then we're going to run the unit tests. And so this is where you need that pod name right here. I need to get that pod name because I'm going to go into Kubernetes and I'm going to execute and say, on this particular pod in this particular namespace, please run our unit tests. That's what this does. You see SQL command right here? That's exactly what this does. For this specific project, run exec tsqlt.run all. And finally, actually almost finally, we are going to save those test results. So again, tsqlt, amazing. It actually creates test results in an XML file if you ask it to, so that, and I'll show you this, at the end, you actually get those test results, so what passed, what fails, right in your pipeline builds in a really beautiful format. And that's what we do next. We get the XML files out, and then we publish the test results. Let's see where we are for our build. It usually takes about 10 minutes. Still deploying the DAC packs, but it should be done in about a minute. And then finally, we clean up, right? We have a limited amount of space on Kubernetes. Kubernetes is based on the number of VMs that you set up, even AKS, Azure Kubernetes Service. I have currently a 2-node node pool. So a node is like a VM. And so I've set up 2 Windows nodes in my node pool. But it will run out of space and eventually just stop deploying if you don't go ahead and clean up your namespaces. So this last task is to go ahead and clean up your namespace so that you can run as many pipelines as will fit on the number of nodes in your node pool. Again, if you have auto-scaling, it's almost like you can run all the nodes or run all the pipelines. So let's go look at our 20 seconds maybe, 20 seconds more. So while we do that, I'm going to make sure that my VM is up and running so we can prove to you that this is actually what's going on. So let's switch to SSMS. So this is SSMS. Maybe my pointer will work on this one. Yes. OK, perfect. Up here, we have an IP address and a port. The port is not the standard port, for obscurity. But this is actually a developer instance of the container running on Kubernetes, so I have something to play with normally. This is what our container should look like when we get a chance to inspect it. So if I open up databases, I will see, because our particular demo has AdventureWorks source and target. It's just the OLTP version of AdventureWorks and our SSIS DB. So when we look at that container that's going to come up, we're going to see AdventureWorks source and AdventureWorks target, because that is what Sreeja defined in the Docker file. That's what defines what's in the container. Let's go back and look up to see if it's done. All right. Ooh. All right. It's publishing the test results, which is fantastic. So now let's go look at what's been put out there. We do need our IP address. So Azure DevOps, can this get bigger? I'm not sure that, there we go. So you see this IP address here. When you set up a service in Kubernetes, it will give you an IP address to do ingress on your container. Otherwise, your containers are completely isolated. There's no way to get to them. But we need this because we want to inspect it. So let's go open up SSMS and see what we have. Oops. Here we go. All right. All right, so let's make a new connection. I'm going to use that IP address. I think we're all just going to have to trust each other that this is the right IP address, because I can't see it either. IP address. I'm logging in as SA, because containers don't have Windows authentication. It's very difficult to do unless someone solved that problem. Anyone? All right. No one solved the problem. Fair enough. Let's just look for my password without trying to give it to everyone, although it doesn't matter because this container will disappear in a little bit. All right, here we go. I am going to make this bigger. I'm going to use my handy-dandy password, and I am going to connect. And look at that. This database is going to exist for another 15 minutes before it evaporates, because that's when our pipeline will evaporate, so, or end. And so what we have here, just like the development part of it, where's my mouse? Does anyone see my mouse? There we go. Again, we have, you'll notice, AdventureWorks source and AdventureWorks target, and we have this other special one, this unit test database, AdventureWorks example unit tests. That is one of the things that we just deployed, and that holds all of our unit tests. So let's take a look at those. We don't have a lot of unit tests because it's a demo. But if we look in our programmability, stored procedures, in T-SQL-T, everything is a stored procedure. Gosh, there's a lot of stored procedures here. Let's hopefully, there we go. Here are the ones that I wrote, though. Script stored procedure as crate2, sure. So this is what was deployed. We built a database project specifically for this solution, and this is actually what's deployed. So this is a real database, a real instance running on a container with real tables in them. It's pretty amazing. All right, we are going to go back to our hold on a second. I've lost my window. How is it possible to lose your window? Here we go. Our window. Here we go. All right. And we've published our test results. Let's just go. I wonder if they're going to be published here. They are. Look at this. This is kind of amazing. So we've automatically, right? We've run this pipeline, and we have these unit tests defined, and we've automatically gotten them back into DevOps in a way that's pretty easy for anyone to see. We have 2 total tests, right? It says 2 total tests. One of them passed and one of them failed. And after we walk through the Docker file and all of the magic that that has, we're going to go fix this test. And with that, I would like to hand it over to Sreeja. Sreeja, are you ready?
Yes.
Great.
Thank you, Liz.
Yes.
Okay, so let's see how the Docker file is set up.
You speak to it. I'll get it open.
Okay. Okay, I'm going to show you the Docker file, and as Liz mentioned earlier, all our code is on GitHub. So let's go to our GitHub. Teach for America is the GitHub repository we are using, and within that we have the SSIS CI/CD project. Thank you, Liz, for bringing this up. And before I walk through the code, huge thank you to Microsoft. We started this as using the Microsoft Docker file as the base image, and we built off of that. So if you all want to play with this code after the presentation, go ahead, or you want to have your own functionalities and your own requirements included, you can do that too. So let's begin. This is the Docker file. Before that, Docker file is the artifact which is used to build Docker image, and Docker containers are instances of Docker image. The intermediate environments which Liz showed earlier, which were spun up on demand with all SQL Server included, that was built off the Docker images. So let's go into this further. As you can see, I included the comment that it's adapted from Microsoft's Docker file, and a lot of this file, maybe until lines 33 or even below that, we took from the base file, and then we added some additional enhancements to suit our needs. So I'll do a quick walkthrough of the Docker file. As you can see in line 2, we are saying from Microsoft.com Windows Server Core 2019. As Liz mentioned earlier, Kubernetes requires Windows Server 2019. For our on-prem solutions, we had the desktop version, but because we wanted to show on Azure, we switched to 2019. So you can imagine if you compare our on-prem Docker file and this could be one line of code change between those two. And the maintainer, you could include the person who would be involved in making changes for this file. Right now it's me. And we have some arguments for tsqlt DACpack. Because we are using tsqlt for running our tests, we include a URL for the downloading tsqlt DACpacks. And these containers which we showed in demo today includes AdventureWorks. So this is also provided by Microsoft. You could get the back files for AdventureWorks and start with that. On-prem, we use our own custom databases, but for today to show you, we are using AdventureWorks. And here, these are the links to download SQL Server setup files. And this is a PowerShell configuration to continue. Then here, these are some additional files we included. The line 22 is to include the script for deploying DACpacks. I'll also show you that. And 23 is to change the SQL login. Then we have a script to set up SSIS catalog. SQL Server, by default, when you install, the information services feature is not included. We are copying the master.dacpack and the msdb.dacpack because those are required as well. And here in line 29, so this is the script we had in Microsoft file, but because our pipelines are to do the continuous integration for SSIS projects, over here there is IS included. That was an enhancement we did to use the Docker file they gave. Thank you, Liz. And here we included this additional step to install SQL package.exe. When compared to the on-prem solution, we used Jenkins to deploy the DACpacks, but we saw that it takes a few minutes, and our development team came back to us at that time saying, hey, it's taking a few minutes. I have to stare at the computer while it's deploying. So we made it faster by including SQL package within the file, and now it's taking a few seconds. And here, this is the script to create the SSIS catalog. I'll walk through that as well. And line 45 is adding the deploy script for SSIS package. Then we are including a script to download the tsqlt DACpack, which we configured the URL before, and to download the AdventureWorks back file. And we are calling the deploy DACpack script to deploy both the tsqlt and the AdventureWorks. There is a script to stop the SQL Server. This is as part of the Docker image build. It does not stop it right away. It waits until you run all your tests. And then we also have the Windows Package Manager, Chocolatey. If you are familiar with Linux systems, you have YUM and APT as the package managers. For Windows, it's Chocolatey. It makes things to install pretty easy. So if you see here, Choco install OpenJDK, this one line downloads OpenJDK, installs, sets the environment variable without you manually configuring that. And here we are adding a local SQL Server user because you have an isolated environment You can have privileges as an admin user, and it's going to be removed anyway. So developers would like to have admin privileges in the isolated environment, and that's not going to threat anything. And in the end, this is the command to start the container when Docker brings up the container. That was the Docker file. Let me go to the parent folder and go over the scripts. Let's see this script, create SSIS catalog. And this script is available on the Microsoft documentation page itself. We had to just copy that script, and we didn't have to make any changes to the script. In the SSMS demo, which Liz showed just now, there was SSIS catalog, and that is created using this script. Let's go see the other script for deploying SSIS package. This is also available on Microsoft website. And here we made a change in line 37 to 49 to verify if the catalog is already available, because you cannot deploy SSIS packages without a catalog. And our developers want to deploy packages several times, run tests, and once everything is done, they want to clean up the container. So we added this statement to make sure that it's not created multiple times, and even if you try to do it, it throws up errors. And here we are creating a test project folder where the packages are included. Now let's go back to the other scripts, which is change SQL login. Here we are changing the configuration. By default, there is no password expiration set, and we have seen the containers were throwing errors about the password expiration every 30 days. But because it's again an isolated environment, we turned it off. Not recommended for production environments. This is only for testing purpose. Okay. And finally, let's go to the deploy DACPack script. So this is the script where, for this example, we are using AdventureWorks project, which is a back file, and we are using the restore command to restore into our database. And in this line, we are deploying the tsql DACPack for our unit test purpose. And as I mentioned earlier, all our code is available. You can go to this URL right now and view the code, or you can make your own forks of that, or you can add more enhancements to this. And I would like to welcome back Liz to talk more about the containers and what's happening in the pipeline now.
Thank you so much, Sreeja. So you can imagine, I think you all can imagine your own particular environment and potentially setting up a container to make it look the way it needs to look so you can run your own unit tests, right? So what databases do you need? What information do you need on that particular SQL Server instance? You do that right in the Docker file. What else do you need to deploy? You can have these PowerShell scripts. It's so powerful to be able to set these up within 10 minutes, run your unit tests, and then just get rid of them. It's so incredibly powerful. So thank you so much, Sreeja.
Thank you.
All right, our next demo. I talk about unit tests a lot. Sreeja claims that the developers on my team love unit tests. I think this is a big claim. But I love them because they encompass the business requirements in code, and then those are checked in. So when you run your unit tests, you should know, does my SSIS package meet my business requirements? You can write a unit test for that. So let's go ahead and look. Let's look at one that we saw one broke, right? We have one that fails. Where is our happy, our unhappy? We have a failed unit test. Does it even tell me which one? It does. Look at that. So the SSIS package we're about to look at is written by me. I have, let's say, limited work in SSIS because that's just not my immediate role. So please be kind. I'm asking for a lot of grace here, and we've done something super simple. So in AdventureWorks, in the person database, or schema rather, there is a person phone table. And what I simply do is I take the person phone table from the source, I truncate the person phone table in the target, and I load some of the data in. But I've created a couple of little filters. So what do my little filters do? Someone came to me, some business user in some world came to me and said, you know what, I really don't want any phone numbers from Maine to show up. I'm picking on Maine because it has one area code. All right, so let's look at this just ever so briefly. We have our package person phone load, and you will see in this package that we do something pretty simple. As I said, we do the truncate, and we have like a filter. And what I've done is I've written two tests. I've written a, hey, when the test of the SSIS record, test SSIS, when the record is rejected, make sure the record's rejected when the phone number is from Long Island and when the phone number is from Maine. So hopefully it will let me load both of those. And the one from Maine works just fine, and I will show you what that looks like. So here we go. Let's look at the package. Truncate the target table, load the target table. And when you look and load the target table, this is some random business request that all numbers outside of New Hampshire, Maine, and Vermont should not make it to the target table. So if we look at that conditional split, again, super simple. Can I make this bigger? No, but I can show you all with my handy-dandy magical pointer. So you'll see here, I do a find string on the phone number. I'm looking for these particular area codes. And when it's equal to 1, I move it in one way. Otherwise, I go the other way. That's basically all that happens. And so in this super simple model of what the world looks like for this particular request, I have, let's show you the main one first, because they're going to be so similar. T-SQL-T, again, is amazing. I cannot say this enough. We set up this SQL stored procedure. We set up the parameters. Actually, just quick question. Who has run an SSIS package just in SQL, using T-SQL? Great. So a couple of you for sure know what this looks like. You set up the parameters required for running the SSIS package, like the package name, the project name, the folder name. There are some execution parameters that you have to pass, like the execution ID and a reference ID, potentially. We're not using references so much. We have some catalog variables, like is it synchronized or not, right? We really want this to be synchronized because we do not want to have our stored procedure end before our SSIS package ends. That's critical for our unit tests. Then we set up some project variables. You'll notice I have two connection strings, basically, one to my AdventureWorks source and one to my AdventureWorks target. And then I do this amazing thing in T-SQL-T. We fake some tables. I fake a source table, and I fake a target table. That's what lines 37 and 38 do. And then I insert into my fake source table just the data that I'm interested in testing in my unit test, because I don't want all the data forever. Like that's not a unit test. That's just a massive test. Unit test is supposed to be a small unit that you're testing a specific thing. And so I go ahead and fake my source table, and I put some information, some data into that source table. And here are some of the phone numbers that I put in. And I believe that 207 is Maine's area code. So I create an expected table too, because I'm going to compare them after I run my SSIS job. So I go ahead and say, at the end, 207, the area code 207 should not show up. And if it does start showing up, fail this test, please. So that's my expected. I run the SSIS package like it's an incantation. You have to follow it exactly. You set up your create execution. You have your parameter values. And basically, you hit go on line 87. Start the execution. We've had is synchronized, so it's going to wait until your SSIS package is done, and then you check the results. That's what the unit test is for. You have a known data going in. You have known data that you think should be coming out because your SSIS package is supposed to work a certain way according to your business. Let's assert that that table that you expect actually comes back, matches your actual. Does that make sense? So this is my main one. Long Island is broken. Long Island is totally broken. And the reason Long Island is broken is, as you will see, Long Island it's all the same up top, but I've changed my data. My Long Island data, it starts with a 516. Not all the numbers in Long Island, but many of them do. And so when I run this test, because my filter is not set up, because I'm not meeting those business requirements, it comes through and the test fails. And isn't that kind of awesome? I think that's kind of awesome. So let's fix this. We can fix it one of two ways. We can say, actually, we have not met the business requirements and Long Island should be filtered out. Or we can say, you know what, this test is just straight up wrong. I'm going to assert that you should be writing your unit tests first and they should always fail until you've written your code. And that's how you know that you're done. So let's go fix the code. And since we have a lot of SSIS savvy people here, if I make a mistake, I hope you will all tell me. All right, so I'm going to add the output name. It's a little bit small. This is going to be Long Island's based phone numbers. And I need to do my find string condition. Paste. And let's say this should be 516, right? This is the smallest writing ever. All right. I think that looks good. I'm going to say OK. I'm going to build my package. I'm going to build the whole solution. Why not? Let's just build the whole solution. Let's see if this works. Why not? Can I make this output bigger? No. All right. I can see that it says build 2 succeeded, or up to date. 0 failed. So I think we're good to go. So now I've just done this development thing. My pipeline is listening. Whoa. This I knew was going to happen. All right. Did I unplug something? My pipeline is listening while we get this back up and running. It's listening for me to actually commit to my master branch. Let's see if we can get this up and running. Hold on a second. Ha. My VM is gone. As you do. Or is it my, hold on a second. Is it possible my Ethernet's not working? No, I don't think it's possible. All right, we'll try one more time. All right, let's do some on the fly. Connection error. Is the interweb broken? Or is Azure down?
Did you break the internet?
I think I broke the internet. I think that's what it was. All this talking about unit tests, which I know everyone loves, the internet is broken. Is
This
it
never
possible?
happened.
Hold on. We can save the internet. It's going to be done.
Can we connect to Wi-Fi?
That's what I'm. All right, everyone else, shut off your Wi-Fi. Is Wi-Fi good? Who's on Wi-Fi right now? You are? OK. Wi-Fi still works. Fantastic.
Okay, good.
Whew. All right, let's try this again. Yep, Azure works again. Fantastic. Let's bring back our demo. And really, we're down to the last thing. We just need to check in our code. Like, come on,
Awesome.
people. We can do this together. I feel good about this. All right.
So Liz did that on purpose to demonstrate what it would look like if you lost your connection. And I think she deserves a round of applause for that. That's excellent demo.
Thanks, Andy. All right, we're back. Look at this. Look at this. Oh, and so my VM didn't die. That would have been more horrible. I'm so glad we just lost our internet connection briefly.
But we have more VMs, so we
It's
can
true.
bring that.
It's true. OK, so now, I'm sure a lot of you use Visual Studio. We're going to go to Team Explorer. We're going to see what changed. The only thing that should have changed is that, oh, that's interesting, that changed. Did I not save my changes? Hold on, maybe it really did something bad happen. No, that's the only thing that changed. We updated our file, so that should be the only thing that changed, that package. And what I'm going to say, because we shall live commit messages, is updated logic to include Long Island.
Now, before you commit this, I just want to stop and share for a minute that this is a dream that I've had for more than a decade. And I'll talk some more about this on Friday in my presentation. But what we're about to do here, using a data engineering, data integration platform, is what Node and JavaScript and C# developers have been enjoying for at least a decade, probably 2. And it's automation where you check in code, and then it fires this process that builds, deploys, tests, and then provides you feedback on this. And you've seen it already in the earlier demo where we had one test succeed and another fail. But those tools that we're using now for this operation were built for these very stateless platforms, which is great for stateless platforms. But when you think about including data in this, by definition, data is very stateful. And so now it's easier, I'll say it that way. It wasn't impossible before, but you were writing a lot of your own code before to do this. And what we're going to do is see this test. We're going to check in and watch this pipeline fire off automatically, build, deploy, and then test and give us results back from this, from a data-related operation. Oh. Sorry, I didn't mean to interrupt you.
No, that's great. I'm glad you interrupted because that gave me a chance to have this fail, because of course it would fail today and only today. Let's try this again. It's likely, and for all of you that work with Git, it's likely that I did not sync, that there were changes that I did not, first and foremost, when first I started working, which you all should do, and I did not do, and no one said anything. We need to sync our repository before we start working, or we get these errors. We assumed, yeah, that's the problem.
Right. That's right.
None of that. None of that. So let's do a pull, because I think there's been more changes. In fact, I probably did some this morning. Okay. What have I done wrong? Incoming commits, whatever. View summary. Great. We did this merge. We can go ahead and push everything, I think. Let's push everything. Crossing fingers. Yes.
And it's not uncommon for Visual Studio to disconnect. When we just saw it, that was a real live disconnection, quasi-connected. Visual Studio will sometimes disconnect from Azure DevOps.
Do we see the new build? It was listening for our GitHub repository on the master branch, and that is what we committed to, and there it is. Exactly, yes.
It's doing the new build.
So let's look at that one new build. It is doing basically what I would hope you, well, obviously never manually do again, but it's building our SSIS database unit test project, which we looked at and said, those are the business requirements. We need to change our package. It's building the SSIS project, which we did change to include the filter for Long Island area code. And then it's going to go do the whole thing, right? We're going to go through the whole thing. And I actually am going to hand it over to, this is going to take a while. It's going to take 10 minutes. And I'm not going to make you all sit here for 10 minutes and just wait. So I'm going to hand it over to Sreeja so she can talk a little bit about how we get our artifacts, so those ISPack files, into artifact feeds, Azure DevOps artifact feeds. And then once she's done with her demo, we're going to come and look and come back to this specific pipeline and look to see what our tests say. And they should both pass. That will be what we're looking for. And with that, I am going to change what we're looking at right here. I'm going to bring over Sreeja's demo on how, this is the next part, right? How do you work with artifact feeds so that you can just do what we just did, right? How do you get your SSIS package onto your container? All right, because you can't use normal deployment methods, and Sreeja will talk about that. Thank you.
Thank you, Liz. Okay, so going back to what we talked about, the miracle of DevOps, I mentioned we have embraced artifact management. If you are familiar with other software development languages, they package their code and save it in Maven repositories, NPM, Nugget repositories. What we have done, we have our internal Maven repository, and we extended our database projects to use the same thing. And Azure gives a holistic place for Maven, NPM, Nugget. Today, I'm going to demonstrate how to set up a brand new feed within Azure artifacts. So I'm here, and this is what we currently have for the pipeline which is running. And let's create a new feed, which will be a new place for storing the artifacts for the demo I'm going to show. I'll call this Pass Summit Demo. And it's going to be within the same project. People in the Azure Active Directory will have access. That's the default, not changing that. And use packages from public sources. Depending on your requirements, you can change these config. And we really love the help text and the links Microsoft provides here. So let's go create And here a new feed is now available. And before publishing, how do we connect to this? Let's click the blue button here. Okay, and I mentioned earlier I'm going to use the Maven repository. You need credentials to connect to the Maven repository. Generate Maven credentials. This is all happening live. You can do the same steps if you have Azure DevOps, or you can also try after the presentation. Copy this, and it's important. It says copy to your settings.xml. It's in bold red letters. Do not ignore that. They are not going to store the token, and let's copy that into an XML file. Okay.
Spaces.
Yes.
It's not up there. Do you want me to move it?
Yeah.
Okay.
Actually, just move it. Okay. Thank you, Liz, for the help again. All right. Let me cancel what I have done. For the demo purpose, I had a settings.xml with the servers element, and I pasted the, I included these things, which is not right, sorry. I pasted the credentials, which I copied from Azure artifacts, and let's remove any white spaces. So how did I generate this? Going back here, you will see there is a settings.xml reference. If you look into that, you have an example here. This is the XML file for Maven. It needs certain elements in the configuration. I had a blank settings.xml with the servers element included, and I included the server snippet, which Azure DevOps gave me. Let's go back. Okay. All right. Oops, I'm losing the cursor. Okay. So that's why I did not close this window, because I needed this snippet, which I copied into the template I had before. I think it's messed up. I have to clean that up. Yes.
Line 6 and line 10, right? Is that what you see?
Yes.
6 through 10, rather.
Thank you, everyone, for helping. Okay. So now the settings tag is correct. We have the matching settings tag, servers, and I copied my own server snippet. And why am I copying this? I'll show you in a bit. Let's go to Azure Key Vault.
It's up. It's up on the 3rd tab.
It's up. Oh, awesome. Thank you, Liz.
Oh, 4th, 5th tab. Sorry,
Created.
extra tabs now. Perfect.
Oh, there's a connection error. Refresh. We broke the internet. We brought it back.
Which is cool when you think about it. You want Key Vault if your connection is lost.
Yes.
You want that to be secure, so a refresh is in order.
Okay, so this is the Azure Key Vault, a place where we have all the credentials set up. And as I mentioned earlier, back in the day before we embraced DevOps, the permissions and credentials were spread among almost all the developers. Anyone could go and connect to production and do anything. Nobody has done anything malicious, but they had something in their hands. And we took away all that. We have Credential Vault, and Azure provides its own solution, which is the Key Vault. Now let's create a new credential for the demo which I'm going to do, and I'll call this passcred.
Just a quick survey, who's using Azure Key Vault? Okay, good. A few of you, though. I'd recommend the rest of you look into it if you're doing work with Azure, anything secure.
Okay, so here I'm going to paste the whole XML and click create. The name of my key is passcred. Please remember that, and let's go back to the pipeline. This is the pipeline, and here in these steps is where I'm deploying to Maven. And let me go through quickly what this pipeline is set up to do. It's a subsection of the pipeline which Liz demoed earlier, and it's building the SSIS project using the dev-env utility, and then it's publishing the artifact to the local, and now we want to deploy the artifact into Azure artifacts. That's why we are using the credential key vault, and I just set up the key on Azure Key Vault. And in this step, let me update the name to passcred. Earlier it was passdemocred. When we were creating this demo, that was the name I gave, but this is a live demo. I'm going to use the new credential I set up. And thanks everyone again for helping me with the settings.xml cleanup. And here I have to give the right URL of the artifact feed. So for that, I'm going back to this window which I haven't closed again. I don't need this anymore. Go here and you see there is a URL. Copy that whole URL. We go in this screen and replace the earlier URL that was posting to another feed with this one. And what else we have configured? We have the group ID. The group ID, I'm going to leave it as is. And artifact ID, that's the project name. Version, it's picking up from the build. File is the file which is built now. And in the end, scroll back further. Packaging is the ISPack. And here, the repository ID has to be updated. Okay, let's go back. Okay, I'm here at the repository ID. Let me go get the correct repository ID for the new feed I'm just set up. Where is the repository ID? Right here. Copy this whole thing. Go back to this. All right, finally copy it here, and so we updated the credentials to use the new one. We put it on Azure Key Vault. We updated the URL for the repository and the repository ID. And as Liz showed earlier, this pipeline is also syncing with GitHub. I click save and I commit saying update to use new credential for the demo. because I'm demoing in front of all of you. And commit. On commit, now the pipeline is going to trigger. Let's go to see the pipelines which are happening, which are on build. And you see it's on schedule. Let's go in. Okay, it's building. It's waiting for the console output. It checked out the code. It's going to build the database unit test project, build success. All right. Now it's pushing the SPAC file to artifact feed. Going good. Let's see. Okay, everything is successful, but how would you believe me? Let's go into the artifact feed. And this was the one you had before. Let's go into the new one which I just set up. Do we have something there? Yes, we do. And when did it publish? Just now. So you could publish a new artifact to a new feed on Azure using those simple steps which I just showed. And let's bring back Liz to see how the unit tests are doing.
Thank you so much, Sreeja. So Sreeja just showed us some great functionality, right? Now you can always hold on to those artifacts. Whenever you build, you know that you have them. So now let's go look at our unit tests. Did the unit test succeed? Did the work that we just did before actually work? So I think we click on this one. This was the one right before. Looks like everything was successful, nothing failed. But let's look at the tests. 2 passed, 0 failed. So thank you all, right? We went in, we updated our business logic in our SSIS package to match what we knew the business wanted because that was in the unit test. And now you can be confident every time you run or check in your code that previous business logic that you've been asked to implement still works. QA, if you have a separate QA team, can still be confident that it still works. Your code quality goes up. This is the, I don't know, it's like the top of what I consider like the DevOps. Like you as a developer or a team lead or in management, you can be sure that everyone who's working on this stuff is getting it right every single time because you have this automated and you have it down. So this, between the artifact feed and setting up Kubernetes and all of this stuff, like this is what you can deliver, and this is what we've delivered at Teach for America, right? Like Sreeja said, it took us a week, 3 to 5 days to push out even the smallest changes because we had to do full regression testing. Now that we have unit tests, we were out in 24 hours. 24 hours to get value to our business because our QA team felt confident, we felt confident because our unit tests were working and we had all of this set up. So those are the 3 demos we're going to give you today. We would like to move on to this next piece because we just have a couple minutes left. We want to talk a little, so thank you all for working with us through these demos and through the internet connection problems. And I would like to give a shout out to some very important people. Like this was a big effort, but some very important people whom without the guidance of these people and these communities, we would not have been able to show you this today, right? The last 3-4 weeks, the last 2 years especially, we have relied on these people for technical guidance and their kindness just in spending their time with us. So Andy Leonard, first and foremost.
Thank you,
Thank
Andy.
you so much.
Thank you.
Technical advisor. Yes. Big round of applause. As I say here, indomitable cheerleader and just a wonderful ally to get us up and talking this year. This is our first year doing this work, and here we are at Pass Summit with him. So it's amazing.
Good job.
I would also like to thank Senior ITL Peter Gluck, who leads up SED, and our Senior Information Technology Leadership. Obviously, all the teams we work with, like data infrastructure operations, DevOps, WinOps, and the data platform team, and the kindness of the NYC Kubernetes community, who I started with them a year ago and knew nothing, and they helped me set up this cluster so I could demo on it today. Like, this is pretty amazing. And then he's not here today, but I'm definitely shouting out Sebastian Miney, who put together T-SQL-T, and that is what we rely on as an organization now to ensure that our business requirements are being met every single time. Every time we change that code, and just randomly when we run these pipelines, right, to make sure that we are delivering the right thing. So, looking ahead, we do have some challenges. We've had a lot of successes, but we've had some challenges. We don't have a ton of time, so I just want to focus on what Sreeja has to talk about with unit test quality and quantity, and then I'll just say briefly about yet another tool to learn fatigue. So why don't you take it away, Sreeja?
Sure. Thank you, Liz. So I said our developers love writing unit tests. Not everyone, to be honest. But they are getting up there, and some of them have become experts, and also due to code reviews and pairing, people are learning from others' unit tests. And we do not have a coverage metric for the code. In other software development languages, you could have a number on the code coverage. That translates to business teams, how much confidence level you have on your code. We would love to have the same thing for SSIS projects, but it's not yet available as a feature with the existing tools. And QA is a separate team, and they are no longer waiting for long for something to test. And as I mentioned, some of the developers are like, what is this extra work we are doing? They are database developers, but now why are they writing unit tests? That was one of the comments we got. Not anymore now. People are, soon they'll love unit tests. If you come back to Teach for America, ask in a year, yeah, everyone will love unit tests. Liz, you want to talk about the other challenges?
Just very quickly, I know you all are here because you're excited to learn this and you're excited about Azure and all of the things it can offer. Not everyone is excited, and some people get fatigued because if you remember the vision, right, we had GitHub or Azure DevOps repo. That means you have to learn Git. That's a thing unto itself. We had Azure DevOps pipeline, another huge learning opportunity. Let's call them learning opportunities. Self-hosted agents, setting that up. You have to have WinOps or Linux Ops or whoever you need to help you set that up unless you too are an expert in that work and can make custom images yourself. What else do we had? We had the artifacts feed. Do you know Maven or NuGet or NPM? If you don't know that, that's another opportunity for learning. Kubernetes, I love it. It's awesome. It's also a steep learning curve. Setting the containers up. T-SQL-T, amazing. Still takes a little bit to learn. And then finally, there are tools that are missing here, which I think Andy's going to talk to you on Friday, again at 11. Which are also going to be another part of your learning opportunities, either for you or for your team. So there is yet another tool, learning fatigue, that you can run into and hopefully get through. So,
yeah.
Andy, do you have anything to add to this slide?
No, I think that's a good overview of challenges that anybody trying to practice this is going to run into. Nothing we said, I think, you shouldn't take away from this that this is easy. It's not. It's complex. But will it make your life easier? Will it add confidence to your organization? Absolutely. So.
And it's fun. I mean, really, we've had such a great group of people coming together with all of us to learn about this and to put something together that's really cool. So we've had a great time. And we would all like you to have a great time too. So we have published all of this on GitHub. If you have comments or questions about what's up there, there's many README files, there's live code, like you could run this yourself. There's how to set up Kubernetes on AKS with a Windows node pool. All of it is up there. Questions, please, we're happy to help. We're happy to update the code. We'd love for you to take this on and give us feedback or let us know how to do it better. T-SQL-T, again, amazing. It's like networking, but for unit tests. And we'll end with session evaluations.
Yep, well, we'll end with thank you.
Oh, well, thank you, obviously.
Remember yourself.
Please fill them out. Please fill them out. This is our first, obviously not Andy's first year. Andy's amazing. But it's our first year speaking, and any information that you want to, the feedback is a gift. And so if you want to give that gift to us, we would love to hear it.
Did they not do an excellent job?